Welcome back to the OpenShift Coffee Break this morning, this December 15. We're close to Christmas, and that's why we have this beautiful background. Hi, everyone. My name is Natale Vinto. I'm a product marketing manager for OpenShift here in Red Hat. I'm with my awesome colleagues. I will start from my great friend and presenter, Tero. How are you, Tero, today?
Hi, fine, awesome. We have snow and winter is coming. Winter is actually already here.
That's a typical awesome Finnish enthusiasm, right?
Yeah, everything is awesome. That's the Finnish optimism. Yeah.
Hi, Tero. Welcome back. And today I have two awesome co-hosts, my friend Fabio and Andrea. Welcome, Fabio and Andrea. How are you?
Welcome. Hello, everyone. Nice to meet you here for the first time.
Andrea, how are you today? I can't hear you. Not yet.
You can hear me.
Right.
Greetings from London. Hi there.
Hey there. Oh, from London. Nice that you say that, because we have a super guest today, our friend Alex. How are you, Alex?
I'm okay. I'm also not that far away from London, so it's certainly not snowing here, but it's quite a reasonable day for the UK in winter. So yes, and I'm doing fine and looking forward to presenting today.
Awesome. Welcome back, Alex. We had Alex in some of the previous show. I don't see Andrea. Andrea, here we go.
Twice.
Andrea is twice. Fantastic. So sorry, Andrea. I know you are important, so we went to you double in this setting. Alex was there last time. Awesome demo about Cloud Native app. Today we're gonna do another awesome demo, Cloud Native app, but in the serverless way. Does anyone want to start begin telling some story about serverless? No volunteers? Tero, I know you're a big fan of DevOps. What is serverless for DevOps?
It's easy because you don't have to maintain servers.
That's right.
It's just, if I compare it to just normal deployments, it is just deploying a lot of revisions of your workload and more often, and not having proper metrics since you have short-living objects. So yeah, it has its benefits, but also there are some cons that you need to take care when running something on serverless.
Probably the serverless, the naming serverless is misleading because it looks like it's something focused on infrastructure, but actually the serverless framework or serverless approach is more for developer. If you agree, guys, no? So it's a new way for developers to just focus on the business function they need to solve, or the code they have to prepare for, and that fits a specific business function, instead of focus on the performance of the servers. That could be, as Tero told yesterday, useful for warm your house, mainly if you are living in the Nordics, but actually probably for a developer team, in some cases, not so always, but could be just another things to worry about, but is not needed for the end user, business user.
I would agree with the naming is a little bit confusing, but hey, I'm a developer. Serverless is an abstraction for developers. It's a different design pattern for them to use to build their applications that allows them some distance from that infrastructure. It allows them something that will scale up very naturally according to the load, and equally scale down to nothing to actually help free up resources for other applications, or potentially, free up the whole server entirely, so that you actually have, much lower cost systems, or be able to run more on that one system because you can share out the resources between more applications. So for the developer, it's an abstraction. For the operational team, it's a potential way of reducing the number of servers they need to run, or servers they need to have to back up all the applications that they're actually got running.
Sorry, I wanted to say for the people attending the show, if you have any question, please send the question in the chat. We will go today with another awesome live demo. Right, Alex? It's live, like Tero teach.
Oh, absolutely. Nothing like flying on the seat of your pants, as it were. Absolutely. There's little point in doing these things unless they're live. So yes, we've got some slides. Apologies for that. It feels a bit corporate. But amongst all this, I've got about 5 demos to take you through some serverless examples, which will hopefully keep you happy.
Awesome. And I wanted to say that this is our first time on the new streaming platform. We're testing stuff here, thanks to our colleague for helping us for the assets. This graphics is from Alex. It's a very nice Christmas graphic. And if you look on the top right, you will see Tero with a red hat on top. So it's something we wanted to do. We're playing with the new streaming platform. It's very cool. I hope you enjoy our graphics today. So folks, I think we have some slides before we go into the demo, right?
Absolutely. There's a whole pack of stuff that will take about, I don't know, just over half an hour to run through, including some demos. But absolutely, please put some questions in the chat. We'll tackle them as we go, or possibly at the end we'll do a recap and see what we've seen.
Perfect. So let's go into this slides that we have today. So Alex prepared some slide, and let me remove this caption here so Fabio it's visible as well. Alex, if you want to introduce us to the topic of today, we are looking forward to make you difficult questions.
Oh, great. Okay. So welcome. As I said, Natalia's already introduced me. I'm Alex Groom. I'm a senior solution architect at Red Hat, and today the title of the actual presentation is actually an eventful journey of resources and responsiveness, because that's what we're going to look at. We're going to look at how resources and responsiveness kind of compete against each other in this particular topic. The subtitle was taking our website serverless, but Natalia said the whole thing was too long for his deck, so we just kind of shortened it. And that's exactly what we're going to talk about: how to take something concrete, something we understand, like a website, how we can make that serverless. What are the pros and cons of that process? How would we perhaps go through that activity? And that's the action today. But bearing in mind, resources is actually a key element of this as well. And kind of with that in mind, I mean, we tend to believe the internet is clean. Lovely picture here of clean nature, etc. But yes, we've significantly reduced the use of paper by consuming stuff online, which is good. But the internet hasn't become carbon neutral. Our digital lives do have environmental impacts, even if we can't see it. So, when you browse the internet, you visit websites. Each website is using power, lots of servers in a data center somewhere typically. So you're consuming energy, and apparently 2% of our global carbon emissions come from the electricity used by the internet. So it's not a minuscule thing. It is actually something that has an impact with what we do. So yes, we could reduce web traffic. Can't see that happening. We could host all our data centers right next to renewable energy sources. That'd be good. But realistically, perhaps what we need to look at is looking at the resources we're using for web traffic and for building websites to see if we can improve our carbon footprint. And this is obviously a very topical subject at the moment with global warming and climate change. So going back to the topic of the title, which was taking our website serverless, we need a website. Now, I could have gone into a really complicated, intricate website, but that would take a long time to explain and take you through. So here is a simple website that we're going to use today through a selection of demos to get you an idea of what we're talking about. Very simple, and Natalia will be able to tell you all about this because it's featured in his new book that he's just written. A matter of small number of services. We've got a web front end, we've got an orchestrating microservice in the middle here, and 2 data-driven services. One's called the catalog service, and the other called the inventory service. And what they're delivering is a web front end. It's a storefront, a retail storefront for our Red Hat cool swag. So these various components, the catalog service, for example, is generating the information for the pictures, the descriptions, and the prices. Note they're in dollars. The inventory service, that's the stock levels. That's helping to generate these blue pieces of information, which is, how much have I got of each item. Those two bits of data gets orchestrated in the middle in the gateway service and then rendered by the web UI. And that's how the website is built. So this is our web application that we're going to take serverless. This is the topic. This is the item of the day. But why would we want to take this serverless? Well, first of all, let's have a quick look at what this thing actually looks like for real in OpenShift terms. And now this is OpenShift TV, so I'm kind of hoping this isn't too new for you guys. But basically, we've got a selection of pods. That Node.js is the web UI. We have a .NET gateway microservice that's doing the orchestration. The two data services, one's called Catalog, and that's written in Spring Boot, and I've got a Quarkus inventory service. A couple of databases over here that are providing the data for the various services. And hey, look, no surprise, if I click on the UI, a little bit of a churn, and up comes my website. Now, for the purpose of today, just to keep things simple, we've switched off all the website caching because it makes the demo much more predictable. That's the website that we're trying to deal with today. So it's worth thinking about, what's going on here. Because if we look at the metrics, the monitoring of this stuff, continually, not a great deal of CPU use, but the one that worries me most is actually the memory usage, because we're continuously using 7 heading towards 800 megabytes of memory here. And as you can see, the two big chunks, which is the purple piece and the blue piece down here, that's the catalog and the inventory service, respectively. They're the big users of resources. And that's on all the time. Memory is being used. It cannot be shared with any other application while these applications have grabbed that memory. So the CPU can be shared between other applications on demand. In fact, the CPU usage is pretty small. But memory is kind of fixed. That's one resource that's hard to share. So that's the sort of introducing the CoolStore piece. So why take CoolStore, make it serverless? Well, I got this request from my boss, and he said, hey, it's only a US website. I need those resources overnight. So can you shut down that cool thing when the US is asleep? That way, the resources that website are using can be used for some other application. Maybe there's some overnight testing. Maybe there's another development team in India or something that need those resources. So quite rightly, he says, why consume that stuff while it's doing nothing? Let someone else use those resources. Now, that sounded quite a reasonable request. However, he did follow it up with a little caveat, which caused me one or two issues. He then said, should one of our employees on the other side of the world need something cool, need something to buy something cool, then they better be able to buy it. So basically, he's saying, shut the thing down, but it still needs to be there if someone needs it on that kind of occasional basis. So that left me with a bit of an issue. So I thought about this and I thought, well, okay, what are my options? First of all, I thought about batch jobs because, I'm an old-fashioned guy. I remember the good old days when everything was a batch job. But that scales stuff down. I could shut stuff down, but I couldn't bring it back up on demand very easily. So that didn't seem like a particularly good example, a solution. The other thing I could do is work on resource consumption, just generally slim the thing down. So that would have some benefit. And then I thought, well, hang on, there's this new Knative serverless stuff that everyone's talking about. Couldn't I use that to make this website serverless, to save those resources overnight? Because, it should be easy to do. I've seen all the demos, should be trivial. So let's have a go with that. Now, kind of the topic of the whole discussion is resources versus responsiveness. Yes, I want to save resources. You saw some of those metrics I was showing you a moment ago. But the whole thing about websites is all about user experience. We spend a lot of effort making stuff as responsive as possible, putting caching in, putting in lots of fast data paths. So basically, we will spend resources to make something responsive. And now we're kind of turning it on the head and saying, hey, look, we want to claim back those resources. What is the impact that's going to have on responsiveness? And that's an ongoing theme we're going to look at as we go through this set of demos. But first of all, let's have a quick look at Knative serving. I don't know how much of this you've seen before, but let's have a quick review. Knative serving is all about event-driven serverless containers and functions. And what happens is there's an event that kicks everything off. Now, whether that's a web request or an event from some other source like Kafka, or even from an eventing platform that we'll look at a little later. So the event comes in, your application starts kind of on demand. And if that event source goes away, then at some period of time, your application will disappear. And that's actually great for the solution, for the type of problem I've got here today. So just to recap, what serving is it consists of an application and then basically 3 other components that are worth thinking about. First of all, there's the configuration. That's a way to separate your application code from how this thing actually touches the infrastructure and the infrastructure uses. We've got a root. That's the way you access this application from afar, from external systems. And then finally, you've got those revisions, which is basically snapshots of previous instances, previous builds of your application. And that can come in very useful if you need to roll back your application at any point. If you have a problem with it, or you find that actually version 3 is actually worse than version 2, so roll it back. So they're the kind of components that you have with Knative serving. But essentially, events come in, your application runs. A lot of events come in, your application can expand to fit that demand. So again, recap, what does Knative Serverless give us? Scale to 0, and that's something I'm going to take a lot of advantage of in this particular demo. It saves resources when the thing is not in use. It scales according to request. That's good. Black Friday comes along, you want your website to go really big. But equally, rollback revisions and particularly traffic management. Built into serverless, you've got this canary type facility where you can actually attribute whatever percentage of traffic you like to your new revision. So maybe 10% for the first time you try it, and you increase up that traffic load as you go on. Now, that's not something I'm going to talk about much today, but it's just a feature of serverless, that traffic management sort of canary deployment is actually built in. And it's fairly easy to deploy. You can literally just use your existing application. And we'll have a look at that in a moment. Okay, so here is my first attempt at taking my cool store website serverless. So what I've done is I've left everything as it was before, apart from taking the web UI piece and said, okay, let's make this serverless. And that's what we're going to look at first. So if I go back to my set of demos and have a look at the topology here. So this is my cool store app with the first step serverless. And as you can see, I've got this big square box on the screen, and that indicates that this item has been taken serverless. The other thing to note is all these are pods, by the way. These have got a nice dark blue ring, and that means if I click on these, you may not be able to see this particularly well, but they've actually all got a pod associated with them. But if I go on the serverless one, it actually says it's auto scale to 0. There's no pod running. So when you see this white circle in that square box, that means, hey, this is serverless, and there is no pod running at all. So this is actually dormant. There are no resources being consumed for this web piece. So let's run it and see what happens. Oops, that wasn't supposed to happen.
And this is all live, just to remember, right?
Yeah.
All live. We could even share the link, I guess, from live in the chat.
Oh, we could do, but best not, because the one problem with serverless is you trigger it, you then have to wait for it all to go quiescent again to it to settle back down again. So let's try and do this again. And that's the problem I've now got. So what I was trying to do is show the fact that the website is loading very quickly based on the fact that the pod has now actually started up. So we can wait for that to go quiescent. We'll have a look around at one or two other things while we're waiting. So how did I create this? Well, there's 2 basic ways to create these serverless applications. The first one, obviously, you can go into the application build that is built into OpenShift here. And as you scroll down, you've got various options. This case is the built from Git. But one of the things you can do is come down here and just click the Knative service box, and you will get a Knative version of your application rather than one which is a standard deployment. The other thing you can do from the topology screen, and this is a fairly recent feature, is you can go and grab your application and say, okay, I want to make this serverless. And there's an option here that says, okay, I'm going to use the existing container that you've built and just convert it to a K service. You may need to change this name to something that you want to use, but you have these 2 built-in features in the web UI to allow you to make your application service. So as you can see, the life cycle of this particular example has now gone black. Basically, all that means is the pod is now terminating. So that pod is now actually no use at all for actually running this application. So I can actually repeat the demo to give you an idea. And I want to give you an idea of how long it's going to take, what the responsiveness of this is like once you make everything serverless. So let's have another go at kicking this off. So as you can see, the pod has gone light blue. That means the pod has started, but the application has not yet started. And then when it goes dark blue, that means the application is actually ready to run. So you see there's a bit of delay waiting for the website to build out, but it is actually fairly quick. And the reason for that is actually most of the application has not been made serverless at all. And that's one of the reasons why things are running pretty quickly. And so this is my first attempt at serverless. So yes, responsiveness still there. Well, what about resources? So if you go and have a look at the resource load, you notice that as the thing starts up, you get a little bit of bump of CPU usage. And down here on the memory resources, let's make this a little bit smaller. It's a little bit easier to see. We're not making a whole deal of progress here, because all we've managed to make serverless is this tiny, a few, I don't know, 30, 40, 50 megabytes. The main bulk of it is still exactly the same. And the problem here is that the web server is only a very small component of the total resource consumption. So when that goes serverless, we're only getting a tiny bump and a tiny claim back. So yes, made it serverless, but haven't really done a lot to tick that boxes in terms of resource consumption. So I'm not sure I'm there yet. So maybe we have to continue this discussion. So the next option is, well, can I make everything serverless? Well, clearly you've seen it's relatively easy to turn those components into serverless components. We can do that. I'm not sure making databases serverless is going to be a great solution, because they do take a long time to start up and they do consume a lot of resources. So I ignore databases. But generally, let's see what happens if we make everything serverless. So here we go, attempt 2. As you can see, Web UI, API Gateway, Catalog Inventory, they're all in these little dotted boxes. They're now all serverless components. So let's have a look, see where that gets us. So I switch on to my next demo. To the topology screen.
A quick question in the
sure
to mess up your line of thought in the demo. But
okay,
there is a framework behind all this. So that means that if you have a tiny piece of application, the framework providing the serverless functions might be bigger than the workload that you're running. So there must be some level of when go to serverless. If you run single website, is the point to do that serverless, or is it just?
I mean, you're absolutely right. To run serverless requires running a sidecar in the pod, so there is a resource consumption. And I think what I would suggest is if resources, if your items are really small, and we'll come on to this a bit later, I think FAS, function as a service, is probably a better solution, rather than actually taking a whole container and making it serverless. So yeah, there are solutions for if you've got small pieces, just functions that you want to run, rather than, in this case, these are services, or this is a demo, so these are fairly microservices, to be honest. But as you can still see, in total, the memory usage for this application as a whole is sort of 700-800 megabytes. And if we can make it all serverless, then we can bring that down to almost 0 megabytes when the thing isn't actually running. So there is still a benefit here. But you're right, there is a cost to running the serverless framework. So ideally, you want a number of people in your cluster actually using serverless to justify some of that cost. But anyway, let's carry on with looking at everything serverless. As you can see in this particular example, now everything is white ringed. There are no pods running at all. So if I kick this one off, we can have a look and see how this behaves. So the first thing you notice, and you actually see it, this is really quite slow, this demo. The pods are starting, it goes blue, then dark blue, and then it starts painting the web framework over here on the right, because the web UI is painting the backgrounds, loading up the JavaScript, etc. But the data is still yet to come. And until the data comes, it can't paint all the graphics and all the information. So what's going on over here? Node.js, the web service talked to the gateway service. It's made a request to the catalog service. So the pod is starting, and now the application is starting up because it's gone this light blue. But notice over here on the inventory service, it hasn't even started yet, because the request comes down through here to the catalog service. When it responds, the gateway service then talks to the inventory service. So we've got a delay here while we're waiting for stuff to happen. So far, yes, I think serverless is working, and we will see that a little bit later. Actually, no, catalog service is now up. It's going to respond. Gateway, the inventory service is now started. We'll now wait for that to start. And when that goes dark blue, the website will paint, which will be about now. There we go. In fact, it's so slow. The web server's almost got bored waiting. There we go. Now, I don't know about you. I haven't been running a stopwatch here, but I would estimate that's about a minute delay waiting for the website to load. So responsive-wise, this is horrible. This is a major step backwards. But I have actually achieved serverless. So let's go and have a look and see see if there's anything we can actually claim back from this. So yeah, great serverless. If I go and have a look at the monitoring, let's have a look. You see CPU, nothing, and then bang, up it comes. Memory usage, nothing, then up it comes. And this will obviously quieten down as those pods wind down, idle down, as it were. The resources will drop. So now I've got great resource consumption, but no responsiveness. So I'm going to have to find a balance between these two to carry on with this. So no surprise, there are more demos to come as we try and fix this problem.
Alex, somebody in the chat said that we can't see the web application. Not sure if we should be seeing it. I don't know if you meant you click it on the the route and to show the store, or I don't think so.
No, what you should be able to see is hopefully the split screen. This one should be able to run it again. So there should be
okay. Yeah, we don't see it. We don't see it. We see it just as split OpenShift. We don't see the other one.
Okay, let's.
So thank you, Sergio, for this note. And Alex, I take the opportunity also to ask to everyone actually. So we've seen that if everything is serverless, it takes let's say 1 minute to start. Can we warm up something? Can we prepare I don't know, containers? Can we make it warm instead of cold?
Absolutely. I mean that's the whole purpose of okay, let's try this demo again, because clearly you've been missing out on some of the features. Let's go back a step to the previous demo, and let's just go through what's going on here. So the reason why I was going back is it allows the other one to go quiet. But if we go now, you should see the split screen.
It's a little bit noise. If you can, please turn off your mic. Not Alex too. Okay, cool. So Alex, I'm bringing back the screen sharing now. We see it. We see the cool store on the OpenShift on the left, and on the right we see the application. So thanks, Sergio, for this spotting it. Yeah, thanks.
Okay, so that was the first instance where I've only got one thing serverless. And again, that's reasonably responsive. So not so interesting. But let's go back and now go to the one we were just looking at, which is where everything was serverless. And as you can see, hopefully, need to wait. Yeah, things are just beginning to terminate. And then we can run that one again and get you an idea of how long it's taking. In fact, if we look at these, hopefully, you see these are still running, and it takes a little while for everything to go quiet. Here they go, terminating. So we're on to so this is the one that takes about a minute. So you can see this again. So if I hit that and then that and then that, now you should see both screens. So you can see as this loads, up comes the web panel, and as the data requests go through the system, you should slowly see. Well, actually, now you have to wait another minute for the website to actually load. So this is going to be a painful discussion while we wait for everything to happen. But this is the downside with serverless, is there is a responsive issue, because you have to wait for all those pods to load. And if we wait and we wait and wait, and if we chat gently around for another 30 seconds, finally, here comes the catalog service. It's still loading the application. That's why it's light blue. When it goes dark blue, it will respond to the data request pretty quickly. And then the request then gets passed down to the inventory service, which then itself has to start up. And as you see over here, the website is literally still black. Here's the catalog service, inventory service now starts. App has now started to load as the colors change and get darker. As it goes blue, it's pretty instantaneous that the website will paint. In fact, there we go. So that's what I'm hoping you're trying to show you. And apologies, I used the wrong screen sharing mode, so you didn't get to see those first time around. But now you can. So hopefully we are in business.
One comment again.
So to recap,
trying to mess up your head again about code boot time. In demos, everything is nice because you have like one node, you pull everything once, then you run it. But Natalia asked about how to improve like the code boot, get it more responsive when you have everything sleeping at night and they have first customers or Black Friday, that you have to understand what has been underneath. You have a node, you have container, you have a container image, you need to figure out how much time it takes to download the container from registry, how much it takes to run, how much it takes the application boot. And if you have a really dynamic environment, so you have multiple revisions running, those are different container images. You have scaling nodes, so you have new nodes coming, those are empty. So there's a lot of things you need to figure out if you do serverless at scale and want to be responsive, like you have an SLO that each request needs to be less than 10 seconds or something. So you need to know what's happening when you design the system.
Absolutely. And you're right, I'm glossing over the scaling side of things. In some respects, that's almost a different discussion. I'm massively concentrating on saving the resources at the moment because, let's face it, the easiest way to make this responsive is to pay up and run these things continuously. But again, if this web application was much bigger, those resources that you're using all the time obviously increases in scale as well. And absolutely, everything is a trade-off. You have to try and work out, do I need responsiveness? Because remember, the responsiveness is only that first use. Once the thing is running, it is very responsive. It is no less responsive than it would be if it was the original example with just standard pods running. So it's only that initial, coming up from idle that is the real responsiveness issue. However, if you happen to be that customer that comes into this website and has to wait a minute for the website to load, you're probably going to be somewhere else fairly soon. So that will be a lost customer. But the next person in will get a fairly reasonable service. So you may be over-focusing on this as an issue compared to all the other things you might want to do.
So solution is to build so successful business. Do you have constant streams of users?
Absolutely. Why not? Go and sell make your service worldwide. Then you've got a good excuse to run it 24/7. Maybe that's a marketing issue, a business issue rather than an IT issue.
Yeah, Tero, Alex, and the other guys, could we tell that probably an event-driven architecture is the paradigm that helps fits probably better in a context of a serverless application compared to a full synchronous communication between the microservices?
I think, it certainly dawned on me that trying to take a website serverless may not be the best use of this technology, but I had a web server and I had something familiar, and I wanted to see how far I could take this particular application with the platform that we have. And that, to a certain extent, is the subject of the next 2 or 3 demos that we're going to go through, is about how we can use more of the platform to make this, to try and solve some of the problems that we've got here.
Yeah, because I was thinking for the sake of clarity, if we need to add a payment service to this website, and probably this could be a good candidate for full serverless implementation, because you don't need always payments or a shipment service.
That's absolutely true. You can look at your website and say, well, the storefront needs to be there all the time, but some of the secondary services that are not used continuously, they may be better candidates, and people will put up with having more of a delay, and that is absolutely true. And I think to Tero's point, this is a demo. If you're designing an application to take full use of the platform technologies, there are other things you need to think about. There are maybe other ways you need to slice up your application to take advantage of the technologies. What I'm trying to do here, as much as anything, is take a familiar type of application, drop it into these scenarios, and let's play around with it and see what we can make work, see what we can learn about serverless and eventing that we could perhaps use at scale for other types of applications. So it's both a combination of a business problem and a sort of science project at the same time.
One good example actually is to Fabio is that we have seen, let's say, last 2-3 years, enterprises moving from monoliths to microservices and to containers. So they are eating the elephant piece by piece. And now actually, what actually I have done in my current work, that you have a container running that have several different REST endpoints. You actually start taking those long-time consuming REST endpoints and implement those as serverless. One good example is that we have is that in the application, there is a single request that takes a minute and a half when user analyzes game. We move that out from the normal enterprise application and implement it as a serverless, so that we don't actually need the resources anymore in the main application to be used for a minute and a half to that single game analysis, because that game analysis happens a couple of times a day. It's not constant. So this is kind of, you start, once you are in containers, you build microservices, then you actually might start splitting some of the functions to serverless. Might not go all, but to be smart in there. So that's another kind of example.
Does make sense.
Okay.
Yeah.
So getting back into the flow here, the problem that we've just seen with the serverless app is that everything is cascading. One thing leads to another, leads to another, leads to another. There is no parallelism here. We are waiting the total delay of starting up all the pods and starting up all the applications. That's why it takes about a minute. And that's not really very good for this scenario. What I want is something like this with these athletes. We want to be able to start things off in parallel. And that's a kind of key feature that we're missing. So what can we do about starting in parallel? And this got me thinking, there's another half to the KE native serverless framework, and it's called the eventing platform. So I wonder if we can use some of that to help things out. So let's have a quick look at eventing. Here we've got some services. They're running, they're waiting for something to happen. And again, what we'll have with eventing, there's usually an event source. Something is generating events. It will get fed into a broker or channel. I like to call it a bus, but I think that's sort of antiquated technology these days. And that broker can then use triggers, which is just a binding between the broker and the particular application, to forward events on to those various applications. And now these triggers can do a bit of filtering, so they don't have to take every event that's on the channel. And that allows this thing over here, this event, to communicate with these services in a fairly selective way. And this is what eventing is. It's a framework for distributing events to applications that are running in the OpenShift environment. This, I think, has some use, because I think we can use this channel to send some wake-up events to our application, and then we can use triggers to then wake up various components of our web service. So I think this has some legs. So just to recap, what does eventing give us? It gives us a framework. That's good. Receiving an event will wake a service. It doesn't have to be a data event like a REST API. Any event will wake a service. It's fairly simple to inject events into an event bus, and I'll show you that in a moment. So this allows us all the service to hear that starting gun, bang, when things start up, so they can all run in parallel. So very briefly, what does an event look like? Well, I could have shown you this in a variety of different languages. It ended up with curl because it seems like a fairly universal thing. This is what an event looks like that you send to an event broker. So here is my web wake-up event, as you can see down here. This is then something I can write a trigger for, or reference a trigger for, to say, when you see this, send the event on to the end service. So this is how we communicate events across the broker and then grab and trigger applications using something like this, a very simple payload. These are just headers. You can see curl command. These are just HTTP headers. So the only other thing I need to worry about at this point is decoupling, because if you're going to scale out this application, I've only got 4 services, but if it's going to scale out, we need to worry a little bit about decoupling. So it's simple to send events to the broker plane fairly anonymously, which is quite handy. It's easy to attach triggers. Again, that's a simple binding between broker and application. So there's no kind of prior knowledge. You don't need to know where the event has come from to be able to selectively grab events off the event bus and then notify components. So that's nicely decoupled. The other thing the platform will do is it will inject configuration. So in that curl example, I actually had to say where the broker was. But typically, if an application is sending events into the broker, you get the platform to tell that application via an environment variable where to send those events. So again, it's decoupled, and being decoupled allows you to scale and allows you to change things quite easily without the applications being tightly dependent on the platform. Okay, so here we go, attempt 3. Everything is still serverless. What I've chosen to do is put an event broker, and this is now being used to kick off the catalog and inventory service when it receives a wake-up event. What I'm using is the web UI. When the web UI gets its first request in, the first thing it does before it talks to the gateway is it sends that web wake up to the event broker, which will then get distributed to the catalog and inventory services. I don't bother sending one to the gateway service because it's pretty much going to get an event anyway, because that's the next thing in the path. So here is my attempt to start things up in parallel. So let's have a look, see what that looks like. So I move on to my next variant here. Should all be getting fairly familiar here. My web server at the top, gateway service, catalog, inventory service as before. These are 2 triggers, and this is my event broker here. This is the console representation of these things. So when the event broker gets a web wake-up call, these triggers will fire and these 2 will start. The only other thing I've got here is called this bind web server. What this is doing is injecting into the web server the destination of the broker channel. So it means the web server doesn't really need to know what it's talking to. So let's give this a while. Actually, let's close this over here, and then you can see what happens. Oops. No, missed again. That's better. As you can see, things still take a fair amount of time. The difference is that the catalog service and the inventory service have already started up very early. They started probably before the gateway service. In fact, the inventory service is now ready to go. It's ready to do work because it's gone dark blue. We're still waiting for the catalog service because it's slow to start up. But what it means is that we will buy ourselves about 10 seconds at a time.
So it's faster.
Well, yeah, that's certainly an option, and we'll get onto some of those options next. So yeah, overall, this is better. Catalog service is finished. Web now paints. But what we're seeing is we're creating some parallelism, but this thing over here is still taking too long to start up, and that's why we're seeing still a delay, maybe about 45 seconds now rather than a minute. So if we kill off some of these, and we'll go back to where we were. Let's go back to the slide deck to recap. So obviously when I did these slides, I think SpaceX had just launched, but so website launch time is critical. We need fast start times from idle to be responsive. So the slowest component, the catalog service, is preventing the whole site launch. That's kind of what we're seeing. And that's taking from anywhere between 10 and 30 seconds, which is bad news. And even though the wake up event is working, you can't magic away that delay. We're just running delays in parallel, and one of those delays is still too long. So the fix, just to quote Tero, he's already there, is to make faster components or make faster starting components. So that's the next thing to try. So here we are. Here is attempt 4. Now, things have changed a little. The web UI and gateway are pretty much still as the same. The catalog service and the inventory service have been rewritten into fast starting components. Inventory was already a Quarkus app running in a Java VM. I've now used the Quarkus native application instead to give it a lot faster start time. So that starts sort of sub-second as opposed to the 10 seconds it was currently doing. So this is now a Quarkus native app. Over here in the catalog service, I've thrown out Spring Boot and written the whole thing in Golang because that now starts really fast as well. So that's the fast start aspect. The other thing I noticed about the whole thing is there is a delay waiting for the web UI to start up for it to then subsequently wake up the other components. So I'm using a different approach here. Still got the event broker. And the event broker is now waking up all of these components. But I've introduced this thing called the K8 event. So this is the API server source. This is API events from the Kubernetes API. So what this generates, among other things, is an event to say, this pod has been created. So why not use that event, the web UI pod create, to kickstart all the other aspects? And that's what I'm doing here with the K8 event, to maximize the speed of startup. So let's have a look, see what that looks like. So things are getting a little bit more complicated here. I'll move this thing out of the way. What we've got, same old pieces as before. Still got triggers to all three components. I've introduced here the API server source, API source. That is a thing that's generating the Kubernetes events. That's things like pod create, pod delete, that type of stuff. However, things aren't that simple because this is really chatty. This tells you far more than you ever want to know. And I need to extract just the bit that says this pod has started. So I've added this thing, this event filter. This is a permanently running pod that just filters events off the event bus and then feeds them back in when it needs to wake up. In fact, if you look at what this thing is actually doing, you can actually look at the logs. This is what events look like. This is what the wake up event looks like. So, we've got a web event there, a bit small maybe for you guys. Down here, the most important bit for me is successfully create because the pod has been created. But you see these little dots here, these are all the events that are not pod create for the web event. So they're all there, all the ones that I've ignored. So you can see the ones that are being filtered out. And that is required because if you sent all those events to the other parts of the system, it would never die. It would never go quiescent because there'd be far too much activity. Okay, so we've got all this sitting here. Actually, the other thing I need to mention, this bind API. This is now being used by the event filter, so it can send web wake-up events back onto the broker channel. Okay, so let's give this a whirl. As you can see, gone sky blue pretty quickly, so it's all starting very fast. And in fact, I don't know about you, but I would say that's about 5 seconds to go from hitting that URL on the website painting. So I'm pretty happy that that's now a pretty responsive site. And as before, you can keep hitting refresh and it's all still working before. So adding in all this framework has actually succeeded. I have actually created a system now that everything starts quickly and everything is now responding almost as quickly when the original request comes in. So I'm pretty happy with that. That's going pretty well. So the next thing to talk about, and this is something that's relatively new to the serverless system, which is functions as a service. Now, this was something that has come in basically since I originally constructed this presentation.
That was my next question. How far we are from this function as a service, but here we are.
It's coming. I think it's still tech preview. I think, but it's coming and it's building itself out and becoming more and more stable. What I've chosen to do here is instead of using that clunky process, which uses, I don't know, 60, 70 megabytes of stuff and has to keep running, I'm now using a FAS filter to filter those Kubernetes events to then send the wake up event into the broker to wake up all the rest of the stuff. So this is like an optimization or an improvement. Personally, architecturally, I think this is a much prettier solution to rather than having that clunky process just sitting there all the time by using a FAS filter. So what does that FAS look like? Well, I did grab you a bit of code. I hope you can all talk Golang because that's what this happens to be written in, but yeah, it's not too hard, this thing. Essentially, I have one function and that's all I need to define. And the important thing here is not so much the context, but the fact the input parameters is a cloud event, but more importantly, the output parameter is also a cloud event. So that basically means that I can take in events using the FAS filter and replace them immediately back onto the broker without having to send them via HTTP onto the broker channel, which obviously has a cost and a time delay. So this is...
Sorry, Alex, this snippet is a Go function, right?
This is a Go function, yes.
And why we're using a Go function?
Because I can write Go. I mean, it could be JavaScript, I guess. It could be written in Java. It could be a whole bunch of languages that we now support as functions as a service. But the reason why it's in Go is because the original code I had was in Go and I merged that into functions as a service. But the point is, it doesn't really matter exactly what language you choose. You're basically writing a simple function in this case to do a filter. And all you're doing is you're getting the event and you can return the event. And by doing a couple of simple searches and a bit of JSON unmarshalling as required, I can go through that event, pick out the fact that it is the one I'm looking for, which is a web event, relates to the web pod starting up. And then down here, I can return the response to say, oh, look, let's send a web wake up back onto the broker channel, which will then be triggered to fire those other components. But the point is, that's it. That is my function as a service. It literally is a single function, and that's all I needed to do my filtering.
But I see you are using the Cloud Events API. So the people that want to implement this not in any language need to include this SDK.
They will need to have. I mean, the thing is, I'm processing Cloud Events. That's what we're processing here off the. That's what the broker channel is processing. So you would need some kind of library, as you say, to actually access those Cloud Events. I mean,
Clear.
They are going to be a data stream. But what the Cloud Event API is doing is allows me to pick into and grab things like the event subject and the event payload and unpack them and unmarshal them a little.
Gotcha.
So yes, you would need some kind of extra support. Even in Go, I need support for this. That's a package that I have to bring in. It's not part of the standard functions of service.
Right.
So that's what my function looks like. Let's have a look at it in action before we heavily run out of time. So final spin of the dice, as they say. Here is function as a service. So things look much the same. I've still got my API source. I've still got my broker channel. I've got rid of that bind server thing. Don't need that anymore because it's directly talking. And here's my FAS function as a service sitting there. And generally speaking, this should be pretty much the same as what we've just seen. As you can see, they've gone sky blue pretty quickly, which means all the pods have started. The application start, website loads using functions of service. And that is my best attempt at taking my website serverless. So we can have one last look at this. Again, very much like the previous application. What's going on, if you look at the logs, is it's filtering. That's where all the dots are. Eventually, it will find a message that's of interest, and it will unpack it. And when it's one that's really interesting, it will print it out and send the event down for the triggers to the web wake up event down for the triggers to then respond to. So it's all working fairly well and pretty fast. I mean, I didn't put a stopwatch on that, but I would say that's, again, sub 5 seconds to load from cold start, which I think is pretty good. So let's do a quick summary, quick takeaway. My website now idles down to 0. We're not in use. Yay, success. But it now responds rapidly when requests arrive from idle. It's nicely decoupled. Event notifications are now used to speed up that parallel starting. I can migrate applications to serverless with no code changes, mostly. But I did have to add some fast start components to when it was really needed. I can leverage the system event stream for faster starting. And I can use FAS to filter broker events very efficiently. So that's where I think I've succeeded. I now have a happy boss. He says, all my resources, when your web app is not in use, he gets them all back, saves him money. But he also has no complaints from his traveling users. So he's a happy guy. But he may be onto something here because, last time I looked over his screen, he had this Wired article up on the screen. And I think it kind of resonates back to where we started with, which is, this was the Wired article. Your website is killing the planet. Modern websites, beautiful to look at, but are they bad for the climate? So what I would say is maybe we can use serverless to help us go green. And that brings us back to where we came in. Okay, so that's my slide deck and demos finished. So let's see if we've got any questions, because I think we've only got about another 5 minutes left.
Wow, Alex, to be honest, it was a very impressive demo because there's lots of stuff and it's a kind of, we went into a climax where at the end we have also the function as a service. We have a bot that right now is writing from Twitch. So for the moment, we don't have any question from the chat. If you have any question, please send the question in the chat. The question I had, you basically answered about the function as a service. I don't know, Andrea, Fabio, Tero, if you have an additional question on that, and then we go into the final appointment reminder.
I used all my credits already.
Yeah, just a side note, Natale, we started this OpenShift coffee break without having a coffee, actually.
Well, that's speak for you. I had my coffee
sounds
shot,
good.
and you have to have your coffee shot. And I want to say hi to Tanya, which is following us with her coffee shot. Tero knows also Tanya. She's following us. She's a redactor now back to /home. So very happy about it. And I want to say hi to everyone following us today. We have a question. When I want to prevent web crawlers from spinning up my pods, what could be a good practice? Oh, that's a nice question, Alex.
It's an interesting question because you're absolutely right. You've almost got a denial of service attack type effect here that your spider goes around and crawls all these websites and starts them all up for you. That's an interesting question. You would have to, I mean, traditionally the way you used to do that, you used to have a note in your website to indicate you didn't want spiders. But on the other hand, if you want search engines to crawl your website and index it, you do have to allow that to happen. So I think that's a really interesting question, which I don't have any immediate solution for. This is the advantage of me building a demo as opposed to building something for real, because you're right. If something is pinging your website on a continuous basis, then it's going to bring all this stuff up every half hour, every 15 minutes, and kind of negate everything you're trying to achieve. And that may well be you have to think about this slightly differently. You have to somehow phase your website so the front page is handled in a different way, maybe from the bulk of your website. And we kind of talked about that a little bit earlier, where you say you break down your web application into stuff that you can afford to have running all the time, a very lightweight aspect. And then the heavyweight stuff actually comes into play as you go a little bit deeper into the website. That sounds like an approach that I can think of at this particular moment in time.
Probably.
So, Alex, we have a few nice comments in the
Enterprise
chat.
approaches.
One is for Tero.
Have a CDN in front. Usually CDN, Akamai, Cloudflare, whatever in front, taking care of those scrapers, and have a index file for search engines in somewhere else.
Yeah, as I said, I mean, you just need to break this out. If you can take advantage of, as you say, CDNs to do that for you, rather than actually having to literally break your website into pieces, then that's a far better solution to be able to break things up in that way. So, yeah.
Oh, Alex, we have a few questions before we close up. There's someone asking, what is the advantage to use FAS in the cloud or Kubernetes?
The advantage in this particular example of using the FAS was it's small and lighter weight than a full-blown, full-size container. In fact, that's one thing, actually, is one thing I didn't actually show you, which is the FAS component here. Let's see if we can find it.
Yeah, I'm bringing back the screen share.
The FAS component here is about 23 megabytes of memory when it's running. Hard to see what the CPU load is. But if we go back a step to where I was using a process to filter this stuff, let's see if I can go back far enough. I think we'll find that the event filter is about 60 megabytes. So for me personally, using FAS was worth 30 megabytes and more efficient and architecturally more beautiful. For you, the advantage of using FAS from a developer perspective is all about, as in abstraction. Basically what you're saying is, this is the most important part. This is a set of functions. All I need is compute. Just go do it. I don't care where you do it. Just go and execute this piece of code for me. So from a developer perspective, it's all about abstracting that away and being able to break your application. If you can break your application down into things like that, then that's a very useful construct. It's a very useful abstraction to have. So some of this is architectural. So for me, it was worth 30 megabytes. Maybe that isn't a huge win, but it seemed a more architecturally cleaner way of doing things, and obviously allowed me to introduce FAS into this discussion, which otherwise I would have struggled to do. So, let's face it, this is a demo, and that's why I'm trying to introduce as many features as possible from the platform.
Thanks, Alex. We're going into the end. There was a Sergio that said that missed the part where Alex linked the event broker with the route in the web container. Probably is he can, as I said, he can go back to recording and see how you linked the event broker with the route. This was his question. I think the route is actually created, so basically missed how the event broker was linked from the topology view. But I think that it comes when you use the topology view and add the link in that way, or probably he missed that part. And
I guess so. I kind of think I know what you're saying. That in this example, the event's obviously being generated by the API source. It goes into the event broker, which is this piece. Now, the FAS in this particular example is listening on every single API event that's happening. It's filtering them down and then putting back on to the event broker the web wake up call when it sees that this pod has started. And these triggers, 1, 2, and 3, I'm not quite sure where we can actually go and look at them, or maybe we can. Not sure how much detail. Oh yeah, well, here you go. So the triggers that I've added are looking for type web wake up as the event that's actually then going to go and trigger the other parts of the application. So the broker is working in a dual mode here. It's getting a whole load of API server events going through it that are being triggered to the fast filter. If we look at this one, for example, this is saying, okay, give me anything that's come off the API server, limited to actually adding resources. So I have done some filtering because that, again, anything you do with triggers, the less you trigger, the more efficient things get. So I have done a little bit of selectivity here that the API server add events are going to the fast filter, and it's turning those into web wake ups as appropriate. So they go back onto the broker. The broker sends them across the bus, and the triggers will pick up the web wake up and send that to these various pods as required to wake them up. Hopefully that helps. Otherwise, I misunderstood your question.
Yeah. I think, yes, he said in the chat, to send the event to wake up the whole stack when the web is accessed. So, yeah, I think you answered. So, folks, we are at the end of this episode. There's one comment there, from Louder TV. Why Tero and Fabio are missing their red dot? Well, for Tero, I can fix it in this way. You know, Fabio is from Red Hat Office, so I think he's
I usually
let me do this. Let me add a Red Hat on top of Tero. No, now Tero has the Red Hat on top, and Fabio is in
Red
the
Hat
Red
as well
Hat
up there somewhere.
So also Alex, and Fabio is in the Red Hat Office, so I think it's it's okay. So folks, thank you very much for attending today. Alex, it was really impressive demo. I don't know if you have resources. What I wanted to share now is an environment where you can try all your serverless demos like this in this environment called Developer Sandbox for OpenShift. I put the link in the chat. If you click on this link, you got a free OpenShift account that you can use 30 days renewable, where you can run serverless application like Alex did. Alex, I'm not sure all the example can be done at the moment on Sandbox, but most of the things can be doable, right?
I haven't tried. The reason why I haven't used the Sandbox for this demo is because to make things move quickly, I've got 5 or 6 demos set up. You will not get that much stuff running in the Sandbox. There is a limit on the number of things you can run in it. But I would have thought you could, with the Sandbox, do something like start with an ordinary app and then go through the phases by actually converting these to serverless and repeat a similar type of experience. And you can do that in the Sandbox. What you can't do with the Sandbox, for example, is build your native version of Quarkus. I think that will be a struggle. The Go thing I actually built outside of OpenShift as well. But all of these things are actually built. All the things in this particular screen are actually built from source. So I just point a Git repository at OpenShift, and these are all built using S2I. So you can do that in the Sandbox. You can pretty much get this sort of thing running in the Sandbox, and that's when you start hitting the odd resource problem. So if you start with this and then convert, you could go through all the phases that I've showed you, I think, but I haven't tried that as yet. But you're absolutely right. There is now a Knative element into the Sandbox, and that should allow you, to the very least, if nothing else, you should be able to do something like this with just one serverless box on the front to give you a little bit of a feel of what it means to have something come up from idle from zero. And also you can hit this with a degree of load and see if you can actually get it to scale out, because you should get some multiple pods running. It should auto scale out. Again, the sandbox is a limited environment. You will be constrained for the number of pods you can run and the amount of resources you can consume. So actually serverless is actually a really good way of making the best out of your sandbox in some respects, because stuff will idle down.
Right, thanks, Alex. If you are interested, you can do the same, a similar demo, this Cool Store app on with Java. If you can download this book, Modernizing Enterprise Java, there are the example from the same Cool Store app, and you can make try. There's a chapter, serverless chapter. You can try the serverless function with Quarkus Funky, which is a framework for Quarkus, allow you to implement fast. And you can try it out on Developer Sandbox. So the same Cool Store with Quarkus Funky. So in this case, it's only Java. Alex, if you have any Twitter handle, any link you want to share for this demo or anything, please drop in the chat. I will forward to everyone. Other than that, I would like to remind you the appointment of today, and I hope this shortcut works. So let me check. Okay, yeah. Go into this link, Red Hat Streaming Calendar. Today we have our schedule this afternoon chat time. Level up, ask an admin. You can see what show we have today. And I would like at this point to thank everyone that joined today. First, Alex, thank you. This demo was really impressive. And the recording, if you are interested, is on the same link. So you can use the same link in the OpenShift YouTube channel and in our OpenShift Coffee Break playlist to see it again in this nice Christmas theme. Then I would like to thank Tero for being an awesome presenter as usual today. And I also would like to thank our new awesome host, Fabio and Andrea, for having joined us. Thank you. Folks, happy holidays. Happy holidays if you have your holiday winter break. And see you soon. See you next time in January. And the appointment would be January, probably the January the 5. We will announce it, and you will see in the streaming calendar. But see you in January with the next appointment for the next calendar year. At this point, folks, thank you, everyone, and stay connected at OpenShift TV this week, and have a happy week and happy holidays. Thank you. Bye-bye.
Cheers. Bye-bye.
Thanks, guys.